discuss in details about the electromagnetic wave, or we can say whatever we have presented here in the whole array of the frequency range and the wavelength range of the electromagnetic wave, it is also called the electromagnetic spectrum. So as it is a wave and which is generated by due to the accelerated of charge, and in this wave we can find there is a electric component, electric field component and the magnetic field component, both are perpendicular to each other, and this wave passes in this vacuum at a space in the velocity of light, 3 into 10 to the power 8 meter per second. If we observe here, this array of wavelength range for the electromagnetic spectrum started from 10 to the power 5 meter to 10 to the power minus 13 meter. If we compare this whole array of wavelength range, then it is divided into different categories basing upon its applications, its impact. If we consider the wavelength range between 10 to the power 5 to 10 to the minus 1 meter, if you take the average of this range, suppose it is around 10 to the power 3 meter, that means it is around 1 kilometer. This is the whole range from 10 to the 5 to 10 to the minus 1 meter. This range is called the radio waves and the wavelength is very large. And if you come to the microwave, here our wavelength range is between 10 to the minus 1 to 10 to the minus 3 meters. Similarly, for infrared it is 10 to the minus 3 to 10 to the minus 6 meter. For visible it is 10 to the minus 6 to 10 to the minus 7 meter. UV minus 7 to minus 9 meter. X-ray minus 9 to minus 12 meter. Gamma ray 10 to the minus 12 to minus 13 meter. So, to realize the wavelength range, I have given some examples so that easily we can imagine the wavelength range of different electromagnetic wave. For radio wave, if you take an average, the wavelength range is like a big building. If you compare the height of the big building, it is, we can imagine this length can be a wavelength of the radio wave is around meters in this kilometer range. You can say it is 100 meter, 200 meter, 300 meter, 500 meter, even 1000 meter, because the range is 10 to the 5 to 10 to the minus 1 meter. And to visualize it, I can just give an example of the building. So, if we come to the microwave range, it is 10 to the minus 1 to 10 to the minus 3 meter. So, if we compare this in our day-to-day life materials, this animals, plants, in case here you can find the honey bee. The length of a honey bee is that if you taken the average of this wavelength range, the length of this honey bee, it might come few centimeters, and this wavelength range will come under the microwave range. That means you can imagine the wave which is having a wavelength of the length of the honey bee 2 meter, 2 centimeter, 3 centimeter like this. Then come to the infrared. As we are approaching from this radio wave to gamma range, gamma wave, then we can find this wavelength is decreasing drastically. First from the building, then it is honeybee. Now we are coming to the infrared range. In the infrared range, then again the wavelength squeezes and it is like a needle point. It is 10 to the minus 3 to 10 to the minus 6 meter. That means it is equivalent with less than 1 mm also. So, in this small wavelength, like a needle point, the distance of the needle point, it is coming under the infrared category. So, when we are coming to a visible range, that the sunlight is coming in the visible range. In this range, our wavelength range will be 10 to the minus 6 to 10 to the minus 7 meter. And if we compare this dimension in the length scale, you can find it a protozoa, like the unicellular organism. Is a very small, you can say it is a collection of few molecules only. This is coming under the visible range, and you can imagine how small the wavelength range in this visible region. Then come to UV. In the UV region, again the wavelength squeezes are becoming more smaller. It is 10 to the minus 7 to 10 to the minus 9 meter, and it is equivalent to a molecule. That means just a combination of few atoms, 3 or 4 atoms, it is 10 to the minus 7 to 10 to the minus 9 meter, which is called which can be compared is like a molecules. Yeah, 10 to the minus meter also we can say this is around a nanometer scale. In that, so we can find this UV range, the wavelength is equivalent to the length of a molecule. Then come to the X-ray. Again, we can see the wavelength becomes smaller, smaller and more smaller. In the X-ray, we can just imagine the wavelength is just so small, it is equivalent to the diameter of an atom. So we can compare the wavelength is just so small for the X-ray, it is equivalent to the diameter of the atom. Then if you move to the X-ray to further, you can imagine now we have reached the diameter of the atom, that length scale. When we again come to the next stage, next electromagnetic wave, it is gamma ray. And the wavelength range is even more smaller than atom. You imagine if it is smaller than atom, then what would be the length? Obviously, it is the dimension equivalent to a nucleus. So we can say this atomic dimension is mostly 10 to the minus 10 meter. Yeah, we can say in the Armstrong. And again, this gamma ray is again more smaller. It is 10 to the minus 12 to minus 13, and the dimension of the nucleus, which is inside the atom. So now we discussed how small of this electromagnetic wavelength spectrum, electromagnetic wave. Yeah, this ranges radio waves, microwave, infrared, visible, UV, X-ray and gamma ray. And also we compared with the different organisms, atoms, molecules and the buildings to just visualize the length scale. Now come to their energy. So if we see this radio wave energy, as we know, we can calculate this energy from this frequency. So if we compare this energy of this radio wave with minus 11 to minus 5, it's a very, very small energy. And the energy we have presented here in terms of the electron volt. So minus 11 to minus 5, this electron volt is very, very small, even it won't affect us. Then if it is a microwave, it is minus 5 to minus 3. 10 to the minus 5 to 10 to the minus 3 electron volt, it is also very, very less. Yeah, 1 by 1000 of an electron volt. It is very, very less. It never affect us, any animals, living beings. But when it is coming to the infrared, it is coming 10 to the minus 3 to 10 to the power 0. Here 1 by 1000 to 1 electron volt. This infrared range also the energy is very, very small, very, very little. When you jump to the visible region, it is 1 to 1 electron volt. So now we can see in this visible region, the light, if it is the highly intense, it may affect us, because if we go to the sunlight and if it is the noon time, then we may feel warm. That means in the visible range, what is the energy 1 to 10 electron volts, it affects little to this human body, any other living creatures. So when we are coming to the UV, now the energy is very, very large. It is 1 electron volt to 1000 electron volt. That means the UV spectra, the UV electromagnetic wave has high energy, and it is very difficult for any living being to tolerate. Then when we jump to the X-ray, again it is more energetic. The energy is 10 to the 3 to 10 to the 6. That means this is a megavolt. Means 1000 to 1 megavolt range is X-ray. It is very, very highly energetic wave. Therefore, when the X-ray scanning is observed, then other people is not allowed to enter to this room where this test is being conducted. Then when you jump to the gamma ray, it is highly energetic. What we call this nuclear radiations. and it affects severely to the human body, but still it has some applications for us. For the human being, it has some application that we will discuss later. So now we compare the energy level of each electromagnetic range. Radio wave, is electromagnetic wave, radio wave, microwave, infrared, visible, UV, X-ray and gamma ray. Let's discuss their applications. And this frequency range, it is just a number we can calculate from this wavelength, nu equal to c by lambda. These are the frequency. Yes, frequency also we have to discuss because it has the relation with this applications. So for the frequency range, if we consider this radio waves 10 to the 3 to 10 to the 9, 10 to the 3 to 10 to the 9 hertz, it is for radio waves. And if we see the applications, this frequency range is given for this FM, TV or radio signal transmissions. We can have listen this FM radios. When we listen in FM radio, they will first tell this FM radio is having this hertz. Radio FM having some frequency range, and this frequency range is, this radio wave frequency range is given to FM, TV or radio broadcasting system. Then coming to the microwave, this frequency range is 10 to the 9 to 10 to the 11, and this frequency range, this energy can be used for cooking purpose, for satellite communication or whatever the mobile we are using. That type of electromagnetic wave is coming under microwave category. Here you can see this is the telephone communications, we use this microwave range electromagnetic wave. Then come to the infrared. If you consider the infrared, this is the energy, this is the electromagnetic wave, and almost all these material bodies like for human being, chair, table, the room, the plant, all this material object, they radiate this infrared range energy. Therefore, in this frequency range, this energy range can be used for night vision camera. If you are making a camera which can detect this infrared rays, then easily you can detect the object in the night also by sensing the infrared range electromagnetic wave from any object which is there in the night. So it can be used for night vision camera. Also it can also use for the remote controller that we use to operate our television in our room. This remote sensor, it is the remote controller, it is also used this infrared wave electromagnetic wave, infrared range electromagnetic wave. If you come to the visible range, obviously as we know, this is the sunlight, it is the visible range, it contains all the different types of colors that we are able to see. Human eye only can see this frequency range. So here it is used for the photography, for taking a photograph, and also the vision that we are seeing the different objects, it is due to this visible range of the electromagnetic wave. When the sunlight is falling on an object, then only we are able to see. So therefore it is used for our vision and also photography. Next come to UV. For the UV, as we discussed, a highly energetic wave, electromagnetic wave, it is used for the bank node detections. So to check the bank node detection, the UV sensor is used to check this original node is original or it is duplicate. Then X-ray, it is a very highly energetic electromagnetic wave, and it is used for the medical X-ray. If there is a bone fracture, any fracture is happening on the bone, it can be detected through the X-ray test. Then the gamma ray, it is the most energetic electromagnetic wave. As I told earlier, it is this nuclear radiations, it is a highly energetic wave, and it is used to kill the cancer cells. This is, therefore it is written, it is used for the cancer therapy treatment. For the cancer therapy radiation, the gamma ray is used for the patient to kill the cancer cells. Let's come to the visible range. What I have told, it is the sunlight. in the visible range also, the different colors we can observe in this sunlight, starting from the violet, indigo, blue, green, yellow, orange, red, etc. So this 7 colors lies in this visible range. In the wavelength range of 10 to the minus 6 to 10 to the minus 7, frequency range, the energy 1 to 10 electron volt, frequency 10 to the 14 to 10 to the 15 hertz. So here we can find, if we check their wavelength range, for red it is 750 nanometer, the wavelength in terms of nanometer. For orange is 600 nanometer, yellow 542, green 500, blue 450, indigo 420 and violet 390 nanometers. These different colors have different wavelength range, frequency range, energy. Now we can conclude it that the electromagnetic wave is not only light, there are several types of electromagnetic wave occurs in nature, and we have utilized this energy for the different applications for the use of human being. Then in this video we have discussed the all details starting from this wave, what are the types of waves, how one wave is different from other waves, then what is the basic of the electromagnetic wave, then what are the different types of electromagnetic wave, a electromagnetic spectrum. So if you have any doubt on any of this videos in the any of this wave or the electromagnetic spectra or any point, please comment to us. We will definitely answer your questions. Thank you very much.